Okay, so we talked about average acceleration, which was, frankly, for me, it was easy. How do we find displacement or distance? Now, for a velocity time graph, you can only find the displacement, whereas for a speed time graph, you can find the distance. What is the difference between the two, right? So for velocity, you can have negative values and positive values. Remember, velocity is a vector, so it has direction, has positive and negative, whereas speed only has positive values. So distance is only positive, and displacement, you can have a negative displacement because it is also a vector, remember? Okay, so how do we find displacement from a velocity time graph? You calculate the area under the graph. Again, displacement is, for a velocity time graph, is the area under the graph. Okay, whereby in the positive x-axis you plus, and in the negative x-axis you minus. So let's see, we only have a positive area in this case. Let's change it up. For example, the velocity is now over here. So it's a negative, right? So there's a negative velocity going on here, and this is supposedly minus VI. I don't know. Let's just put VP. Oh, we already have a P there. Let's do VA. Okay. All right. So what happens? How do you find the area under the graph, right? So area under the graph. So here I can say, oh, this looks like a rectangle. Maybe I can approximate it as a rectangle. This looks like a triangle. I can do that. This looks like a square and another triangle. And this guy looks like a triangle. So this is A, area A, area B, area C, area D. And this is area E. So let's say area A is 2, and this guy is 4, and this is 1, this is 5, this guy is a 2. Area, I hope you know how to find the area. So it's for a triangle, it's 1/2 times base times height. And the square, takkan tak tahu, okay? So you do that yourself. So how do I find the displacement for this question? So displacement is from, let's say, this is point A and this is point B. So the displacement from point A to point B is the area under the graph, which is A plus B plus C plus D minus E. You have to minus the area that is below the x-axis, and you add the area that is above the x-axis. Okay? So we're going to take a look at an example later, so don't worry about that. So let's just plug in the numbers. So A is 2, B is 4, C is 1, D is 5, E is 2. So my displacement from A to B is 2 plus 4, 6, 7. 7 times plus 5 is a 12 minus 2. So it's a 10. My displacement is in the positive direction, and it is a 10 in magnitude. Cool. Okay, so let's take a look at different types of graph. We have linear motion with uniform positive velocity. Okay, so this graph shows us a velocity time graph whereby the line is straight, which means that this is U and this is V. When U equals to V, this means that our change in V is a 0, right? Because V final minus V initial. We already talked about this. Which means that our acceleration is also 0, which gives us, this guy is the slope of our velocity time graph, which is why we have a straight line, right? And then this is a displacement time graph. What can we say about this? S equals to Vt, equation of a straight line, positive gradient. So here we can say we have a positive gradient because we are increasing in displacement. Our displacement is increasing, so it's a positive. And our time is also increasing, so that's a positive time. which gives us a positive v. Okay, so obviously you can calculate this if they have given you values. So we're going to take a look at an example later. And then linear motion with uniform negative velocity. So negative velocity, how does it look like? So this is u that is at a minus, u at a minus velocity, right? So let's say this is u equals to minus 0.5, and the v is also at the same value, so that's a minus 0.5 as well. So your line is now at the below the x-axis, right? Because it's a negative. When v equals to net minus u, that is what you get. Okay, so when s equals to minus vt, it's a negative gradient. So you, as usual, you can use the calculation method, or you can draw the triangle thingy. Doesn't matter as long as you understand what you're doing. So delta x, which is the change in displacement over the change in time, will give us the displacement, will give us the slope, which is the gradient, which is velocity, right? And we know that our final displacement is less than our initial. So this is our final point and this is our initial point. Our final is less than our initial, which means that our change in x is a negative. And our change in time is always a positive, right? Because it's a scalar, it doesn't have direction. So this gives us a negative velocity. So a negative gradient looks like this, it goes down. And a positive gradient looks like this, it goes up. Positive gradient, negative gradient. Okay, let's go back to this one now. So we have linear motion with positive acceleration, which is A, and we are taking a look at a velocity time graph. So if I have positive acceleration, this means that my gradient for this velocity time graph is positive because it's an A, right? A is the gradient for a velocity time graph. Okay, so it's going up, so that's right, the gradient is positive. But how does it relate to this equation? So let's see. V equals to u plus at, right? U starts at a positive value, so this is our u, this is our u, and this is our v. And at is your gradient over here. This is your gradient, which is over time. This is your gradient. Okay, what happens if my equation is v minus u plus at? I want the positive gradient, but I am starting at an initial value of negative value. What am I saying? I'm starting at a negative velocity. So let's use a pink pen for that. So I need to be a negative value for u. So this is a negative u. And my gradient should be positive, so I need to go up, right? And this is my final time. This is my final position, and this is my initial position. So my v equals to minus u plus at. My gradient is still a positive, right? Because my change in v is positive, my change in time is also positive, so I have a positive acceleration in both situations, despite starting at a negative point. I just changed this equation here. My acceleration is still positive. Okay, so that was just like, fun fact or to improve your understanding. So we have a linear motion with negative acceleration now. So your basic equation becomes v equals to u minus at. So we are going down. Our gradient is negative. Our change in v is a negative change, and our change in time is always positive, right? Because it's a scalar. So this gives me negative acceleration, right? So v is a positive, u is a positive. So this is the case here. V is a positive. Sorry, that's a u. This is my u and this is my v. They are both positive despite the v at a lower position than u. What if I wanted my v to be a negative value? And I think you already know how to do that if our v is a negative. So I'm going to leave that to you. So let's take a look at this question. Gemma is walking on a straight road. The displacement time graph shows her displacement from home. The graph shows that when t equals to 0, Gemma's displacement displacement from home is 20 meters. So at t equals to 0, right? T equals to 0 is she's already at 20 meter displacement from home. So this is our final point, and this should be our initial point. So at the end of the journey, when t equals to 100, Gemma's displacement from home is a minus 30 because she is here, and displacement is minus 30. Gemma's displacement from her initial position. So they are asking from her initial position, which means that x final minus x initial, or displacement final minus displacement initial. And this is a minus 30 minus 20. So it is a minus 50. Why is it a negative? Because it's displacement. Okay. So now they are asking us what is the total distance that Gemma has walked in meters. So let's take a look. This graph is a displacement graph, which means that it has negative values. But for distance, we only want positive values, right? Despite going backwards, that distance still counts, right? Okay, so why is there a negative 2 there? Let me just erase that. Hello, goodbye. Okay, let's draw blah. Okay, let's calculate the distance. So I'm gonna divide these into sections. So this is section A, section B, section C, and section D. I'm just gonna calculate the distance now. Okay, so distance from section A. So that is, I started at a 20 and I ended at a minus 20. How far did I travel? So 20 to 0 is a 20. 0 to minus 20 is another 20. So my distance is actually, but I have to make it positive. So it's a 40. And then distance at B is, section B is, I traveled from minus 20 and I reached 40. So 40 minus what? Minus 20, positive that, modulus it, 60 meters. And then we have distance C, forgive my handwriting as usual. C is from here 0 to a 40. Okay, I just saja je nak bahagikan dua. 0 minus 40, which gives me a 40. And then distance D is modulus minus 30 minus 0. So that's a 30. So the total distance is 40 plus 60 plus 40 plus 30. That's a 70, 110, 170, if I'm calculating that right. So total distance, whoa, nice handwriting, is 170 meters. So that's the distance, not the displacement. They ask you what is the final displacement? It's a minus 30. You can get the answer directly from the graph. Right? And now they are asking you what is Gemma's distance from home. So here the final displacement is minus 30, but since distance is a scalar, you just make it a positive. So it's a positive 30. So now the question asks you for a displacement time graph. Describe the motion, which means that you need to find the velocity. Okay, so I divided this graph into sections because I love doing that and it makes things easier for me. So how do you find the velocity for a displacement time graph? Yes, you find the gradient. So what is the gradient for section A? So let's do that over here. So the gradient for section A is, it's always the change in displacement over the change in time for a displacement time graph. And that is a minus 6, which is the final displacement, minus 0, which is the initial displacement, and the time is at 3 minus 0. So this is a 6 over 3. What is that? Minus 2 meters per second. What just happened? Excuse me, please cooperate. Okay, so that's 2 meters per second. Okay, so that's for A. What about B? B is a positive gradient. As you can see, it's going up. This guy was going down, so we got a negative gradient. Now for B, we are expecting a positive one. So delta x over delta t, the